So good morning, everybody, and welcome to this seventh webinar of the VALITEST series on organization of test performance studies. So for the one that are following our webinars for the first time, VALITEST is an EU-funded project undertaken by a consortium of 16 partners and built to improve the reliability of diagnostic tests performed in plant health laboratories across the European and Mediterranean region. And you can find more information on the project on our website. Test performance studies are interlaboratory comparisons that aims at evaluating the performance of diagnostic laboratories, diagnostic tests, sorry. And during the series, partners are presenting different steps of the TPS workflow through different videos, webinars, and training activities. So we have already covered quite a lot of steps, and we are now dealing with the analysis of TPS results. So today we will continue the discussion on this topic. This session will be a bit different than the previous ones because we already provided you with the theoretical material through 5 videos that were published on YouTube, on Twitter, and on our website, and that you also received by emails. And the goal of this session is really to have an interactive session where you can ask all your questions. So we already received some questions through our SurveyMonkey survey, but of course you will also be able to ask questions during the session. So do not hesitate to put your questions in the chat. The other possibility is to raise your hand and we can give you the floor. So the presentation, know that the presentation will be recorded. And a link to the recording will be provided on the VALITEST website. So today our speakers are Sébastien Massard. So Sébastien is leading the work package 2 of VALITEST. He is a plant pathologist interested in diagnostic improvement, plant virology, and plant microbiome research. He's currently leading a team of about 10 scientists in plant pathology, and he is also a professor at University of Liège in Belgium. We also have with us Yves Rostow, which is a professor at University of Liège, so in Belgium as well, which is more focused on statistics. And we also have Jenny Tomlinson that is working at FERA. So Jenny is a molecular biologist with 15 years experience in the design, development, and deployment of molecular diagnostic technologies. And she has been involved in many EU projects, including the VALITEST project. So now I think we can start the session. So maybe, Sébastien, I will give you the floor. So I think the idea is to go videos by videos and to get your question on each of these videos.
Okay, thank you very much, Charlotte. So welcome everybody. Good morning, good afternoon, wherever you are. And indeed, we have received by the survey several questions related to the video. There were 5 videos that were presented last week. We received questions on video 2, 3, and 4. So what we can do first, we can start answering the questions that have been sent through the survey. But again, and as I remind what Charlotte proposed to you, feel free really to use the chat to ask your questions so we can answer them progressively. So the idea is to start with the first question related to video number 2. And in fact, this video was on the measure of confidence interval. And the question is it possible to use the formula of statistical when the false positive rate is 0 and so the diagnostic sensitivity is 100%? So yet I may ask to Yves to answer it properly.
Yes, it's possible to use this formula. That's why we used this formula, because it takes into account additional variation. And so if you try to use this formula with 100% or 0%, you will see that you get a confidence interval which is a little bit lower than 100% or a little bit higher than 0%. Because even if you have observed, for example, 10 on 10 positive sample, there is always a possibility that, in fact, the detection rate could be 99% or 98%, and by random choice of your result, you get an observed result of 100%. So yes, it works for 0 and 100%, and it's not the case of more classical confidence interval about proportion. And there were also a question about the minimum number of sample or results to use this formula. There is no strict number, but there is a kind of a rule of thumb that say that you can use confidence intervals about proportion when you have at least 30 results, which is much more than you get from usual TPS.
Okay, thank you very much, Yves. This was indeed the two questions related to the video number 2 on the confidence interval. Should you have any more questions on confidence interval, the chat is open. Based on that, we also received question on the video number 3, which was related on the analytical sensitivity and its calculation. And so here the first question was about if the initial amount of serial dilution change the limit of detection will change. So if the initial amount of the serial dilution change the LOD, what could we do? Sorry, I don't read well the question. Yeah, it's about, is it an interest of calculating the LOD if we don't compare two methods with each other? What about the absolute level? What is the interest of having an absolute level of LOD? Because here the interest is more on comparing these methods one with each other.
So the general framework of the method that we used is totally valid if you have information about the absolute level. But it's also valid for dilution level where you don't have a reference level for your starting material. But if you don't have this reference level, as stated in the question, it will be only useful for comparison purpose, because you won't have, if you change the material, the LOD will change and you won't have the same LOD in dilution for the dilution scale. But if you have the same material and you don't know the absolute value, you can use this method to compare the LOD of different methods which are used on the same reference material.
So we have a comment in the chat that the question was for viral pathogen, because usually for viral pathogen, you don't have the absolute quantity.
I was about to make this precision, because here it's a very difference between viruses and bacteria and fungi that are culturable indeed. Okay, there was a second question, which was if we use the logistic regression to calculate the limit of detection, is there a reference or a norm to cite?
It's a very old method. Logistic regression is very with many different sources. I think that I can go back to some of the latest book, maybe, which will be more up to date for this method, like the book of Nelder and Wedderburn or so on. But logistic regression was invented not too long after the classical regression, so it's almost 100 years old, even if we don't use it so much. So it's very classical, and that's why I start on the first question. That's why we choose this approach with a logit link, so the logistic regression, and not the complementary log-log function. So it's very similar. It's exactly the same theoretical framework, and just one piece of the code is different with logit function, which I exposed in the video, which is the log of the probability divided by 1 minus probability, and the complementary log-log, which is the log of 1 minus log, and so on. Why did we choose the logistic regression? Because the results of those two types of model are very similar, except at the very extreme value. And even for those extreme value, the difference are very slight. And the logistic regression, the model that we used, it's much more easier for access. You can find tools for doing logistic regression or in every statistical tool, even in phone line tool. I think that even Excel have some tools to do some logistic regression, but the complementary log-log regression, it's much more difficult to find. You have to use much more advanced statistical tool, and then it would be easier to use logits for a very slight different result. And if you want, if you use it for comparison, again, if you use the same method for all your comparison, you get exactly the same answer. So it was not very important that those two methods, complementary log-log and logistic, were very a little bit different, but not so much.
Thank you, Yves, because in addition, it responds to the fourth question, which was about the availability of online or Excel tool to do it. So you mentioned there is a possibility to do it in Excel. And what is important to state also now is that in the near future, in the coming weeks or months, the aim of the partner of VALITEST is also to put available a code in R in order to make the analysis of and the statistical analysis that have been proposed here in R from any TPS data or even validation data that you may have generated. So code, documented code in R will be available soon to make this calculation. Okay, there is another last question on the video number 3. It is a specific point related to the beta 0, means 17.52, and beta 1, minus 4.04. What are they, in fact?
Logistic regression is just an extension of the classical linear regression. When you are calculating a classical linear regression, you state that y is equal to a coefficient, which is called the independent coefficient, or the intercept, plus b, which is the slope of the your line. It's exactly the same for logistic regression. Beta 0 and beta 1 are the intercept and the slope of this model. It's not a straight line because of the logit transformation of the probability, but they are the same interpretation as in linear regression. So beta 0 is the intercept of the model and will define the position of your the lateral translation of your model, and beta 1 is the slope of the model and will define the decrease or the increase of your probability with the dilution.
Thank you very much, Yves. And there is a last question for this time for Jenny, related to this video tree, which is the dilution of bacteria in plant extract that we can use for the evaluation of analytical sensitivity.
Okay, so the final part of this question was, where is it possible to read about this? So if I start with that, the place that you want to look first is EPO standard 798. So that's the standard that's about validation of diagnostic tests for accreditation, and that has guidance on how you would go about testing the analytical sensitivity and other performance characteristics for different types of plant pathogen. So for bacterial pathogens, then the guidance recommends a dilution series ranging from 10 cells to 1 million cells, so 10 to the 1 to 10 to the 6 per mil of extract, and that will cover the likely range of limits of detection for most of the types of tests that we're talking about. So the range is slightly different for some tests. The recommended range, that's the recommended range for PCR and real-time PCR and plating. For tests where you might expect a slightly lower level of sensitivity, analytical sensitivity, so ELISAs and immunofluorescence, then you might start, you might not go quite so low. So you might go from 10 to the 6 down to 10 to the 2 cells per mil. I think it's also relevant to the earlier question that was about where we don't have an absolute quantification. So for bacterial pathogens, then it's quite straightforward, and that was actually a nice question to have to answer, because it's quite straightforward. It's in the standard, and that's the recommended range. For viral pathogens or other non-isolatable pathogens, where it's difficult to get an absolute quantity, then we would tend to use relative quantification, and that does mean that it's difficult to compare between experiments. So if we are using the same dilution series in the same TPS, then we can compare the probabilities of detection for different tests using the same dilution series. But it might be possible for some pathogens where you wouldn't normally do that to get a more absolute measure. So for a viral pathogen, you could potentially make an artificial target, so potentially the target sequence in a plasmid, and make a standard curve and use real-time PCR or digital PCR to quantify your material that you're actually using in your dilution series relative to the number of copies of an artificial target, and in that way convert a relative quantification to an absolute quantification. And it might not be a very biologically relevant measure, so the number of copies of the target sequence or the number of picograms of DNA might not be as relevant as the number of cells or the number of spores, but it would at least allow you to have an absolute quantification, which would mean that someone else doing another experiment could compare more accurately, where a relative quantification wouldn't let you do that. So that's just some further thoughts about measuring the analytical sensitivity of different pathogen types.
Thank you very much, Danny, for these detailed responses. So these were the questions about the video on analytical sensitivity. We can go to the video number 4, which was related to repeatability and reproducibility. And the first question was about the meaning of method level, as a method level can be used to compare repeatability, reproducibility of different methods. So again, Yves, could you respond to the question?
Yes, the basic formula that we provided is to calculate the repeatability and reproducibility, so the concordance, accordance, and concordance at the sample level. So for one particular sample with replicates, if you want, you can aggregate those results. You calculate an accordance level for the laboratory level or for the method level. So the average accordance, for example, for a specific laboratory for all the samples that he used, or for a method level. So for the whole TPS, the accordance, the average accordance based on all the samples treated by all the laboratories for one particular method. So you get one result that you can use to compare methods together and tell that one method has a better accordance. So it's more likely to get results which are the same when used on the same samples. Concordance is a little bit different. You can, because you calculate concordance between laboratories. So you can calculate it at the sample level and at the method level, but no more at the laboratory level, because concordance is always between different laboratories. So you cannot calculate the concordance inside one particular laboratory, but you can still calculate concordance at the level method. So you can compare the stability of the result between laboratories for one particular method and tell that this method has a better concordance. So it's more likely that different results using this method will have results which be similar.
Okay, thank you very much, Yves. There was a question in for this video related to the replicates, which were a bit confusing. In fact, it's worth to remind what is actually a replicate. What we mean by replicates is the aliquots from the same sample that are analyzed under the same conditions, so in parallel at the same time. This is the key element. And the way to make the the way to make the replicates may vary between the TPS organizer. What we really recommend is that if as a TPS organizer, or if you want to validate in your laboratory the methods, the ideal is that the two replicates, so the two aliquots of the same sample, so we really expect the same result from them, that are analyzed in parallel are in blind, because this avoids knowing in advance that, oh, for these two samples, I should have the same result. So ideally, these replicates of the samples, so really the exact same sample are analyzed, so the aliquots, ideally they should be in blind, and we can afterwards, the TPS organizer or the lab manager can evaluate if the results are in accordance somehow between these replicates. So these replicates can be also understood as replicates from the plant material, if you are sure about the homogeneity of your targets in your material, or it can be from the crude extract or a DNA extract. But importantly, this corresponds to the result obtained by the test on two aliquots of the same sample analyzed in parallel at the same time. And that was the question that we get for the video number 4, related to repeatability and reproducibility. And there was also a 5th video related to the other performance criteria, exploration of other performance criteria. For this one, we did not get any question. So now it's really a good time. If you have any other question, you can enjoy our availability in order to respond to it, to any point that is still unclear in the video presented.
Yes, so you can either ask your question in the chat. You can also raise your hand if you want. And do not hesitate to ask any question, even if it was like something that was not clear in the video and for which you would like to have more information on, or just that you would like the person to re-explain. Do not hesitate to ask, because we are here today for this. So no hand raised.
Or even if our response were not clear enough, feel free really to ask. We are here to answer it.
Okay, so we have one question. I will put it in the chat. So I have a brief question about the controls. Generally, we use positive and negative controls as procedural or methodological. However, it seems that in the TPS, the controls are joined together. So positive control that are extracted in parallel with the rest of the samples. Can I ask a brief explanation on this? Is it planned to include amplification control as well? So I will copy the question in the chat. I don't know. Maybe the question about control, this is more for Jenny. I don't know. I'm not sure.
Yeah, I can just give a global answer that in fact here we did not make specific point on each method, but you can find in the PPO standard for the validation really recommendation for each kind of methods, being serological, molecular, whatever it is. So more globally, we did not go into details, but I will also give the hand to Jenny for a practical answer also.
So yes, we would generally expect to include multiple positive controls because they tell us slightly different things. So yes, you would need an amplification control normally to specifically tell you whether your amplification is working. I think particularly in a TPS where some of your reagents are being supplied by the organizer, but you might be providing others, you're receiving samples which have been shipped, which might have taken a certain amount of time. So you do want to have different controls to tell you about different parts of the process. So your amplification controls to tell you specifically whether your real-time PCR or PCR reactions have worked properly, if there are any problems with any of your reagents or any of the instrumentation or whatever, but that we would also include samples which we would call positive control samples that you need to extract from if there's an extraction process as part of the TPS. So it's difficult to say generally across every single TPS that for practical reasons the organizer might not be able to send out material to be extracted from, so the samples might all be already extracted DNA, in which case the amplification control tells you what you need to know, whereas more generally then you would expect the extraction to be part of the method, part of the test which you're investigating, and in that case then you would also have positive control samples which are, for example, plant material or whatever matrix you're extracting from, a soil sample or whatever. So yes, you would expect to have different controls, multiple positive controls, which are procedural and also designed to interrogate the extraction part of the method. But that it will vary from one TPS to another. So depending on exactly which steps are being investigated. But if that doesn't completely answer your question, then just add a follow-up in the chat or in the questions.
Yeah, and in the meantime, we add another question regarding analytical sensitivity. So to detect fungi in seed diagnostic, we played seed by seed on Petri. We played seed on Petri dishes and observed the number of infected seed on the total amount of seeds. So usually 400 seeds are used. And in that case, is it possible to calculate an LOD?
I think that would depend on the way that you infect your seed. If the seed were exposed to diluted fungi or to diluted bacterial material, and you record it and you apply this dilution to a batch of about 40 seeds, you can use the binary results of those 40 seeds. So yes, the seed is infected or no. And so it would be the same as a test, classical test, where you get a result from an extraction or and so on. So basically, the method can be used to define an LOD as soon as you have a binary result that you have infected or not on each seed, and that you can link it to a level of material, relative absolute infection material. So if you apply diluted fungi extracts, for example, and at each level you apply it to a batch of 400 seed and record the number of seeds which are infected, you can define an LOD for your method.
And to complete the protocol and the methodology that we propose is really aimed to make the calculation based on what say heaves. That means serially diluted bacteria, fungi, viruses, in order to evaluate at which level we do not detect anymore. This is a very important but different question of what is my minimal amount of quantity of seed that should be sampled in a batch in order to have a representative view of the contamination. And the methodology of analytical sensitivity do not address this specific question.
Okay, so we do not have more questions in the chat nor hand raised. So really do not hesitate to ask your question. There is no stupid question. You can also raise your hand if it's easier for you to just speak. So there is another question. I'm not sure about the term independent samples to address repeatability.
And the repeatability should not be done with independent sample. And this must be replicates of the same sample or aliquots. But clearly, yes, you analyze the replicates from the same material. And once you analyze the same materials twice at the same time, you can evaluate the repeatability. So there is not an independent material. It's an independent testing by the fact that you should make two tests at the same time on the same sample.
Yes, I wanted to insist on that. That's the same material, so not independent samples, but independent results. The fact that on the first replicate you detect the pathogen should not influence your results for the second or the third replicate. And so that's why we recommend blind replicates, so that you are not tempted to say, yes, I have detected in the first one, but not in the second one. Maybe I made an error, so I will make a third one. So if you want to really evaluate the method, those should be totally blind and totally independent results of the test on the same sample. And the better way to be totally independent and not influenced by the first result that you get is that you don't know which one are the replicates and which one are different samples when you do the test.
I think if you're thinking about it from a sort of in the lab perspective, it's quite quite a difficult. It's quite a different concept to the idea of your own testing. So if you had a sample that came into the lab, and if you took two samples from the same material, there would be subsamples, and you couldn't be sure that they were the same. Whereas in a TPS, a lot of work, the TPS organizer puts a lot of work into making samples which can be processed independently, but which are identical. So the TPS organizer has to generate homogeneous material and then do specific experiments to demonstrate that it's homogeneous, so that you can have tests with, so that you have samples which are which can be processed independently in order to investigate repeatability, but which we know are the same. Which I think, if you don't think about the amount of work that goes into producing that material and demonstrating its homogeneity, then it's quite hard to imagine samples which are which can be treated independently, but which come from the same sort of original source. You don't normally have a huge amount of homogeneous material which can be sampled from multiple times in order to test repeatability in your own lab, but that's the job of the TPS organizer, to produce that.
Okay, so do you have any more question? I hope the last answer was clear. Otherwise, you can also ask in the chat or raise your hand to ask for precisions. So I will wait 1 more minute. And maybe some of you also have questions on the 5th videos, because we did not really had question on these other performance criteria, but that were proposed by WP2. And so if there is any unclarity, then you can also ask. Okay, so it seems that there is no more question. So I would like to thank Jenny, Yves, and Sebastian for joining today and answering all your questions. I would also like to thank you all for participating to this webinar. So this one was a bit special. Still, we did a satisfactory survey at the end of the webinar or in the follow-up email, and it's really short. So do not hesitate to provide feedback to help us, of course, improve the webinars that we are doing, although we are almost reaching the end. So indeed, so now we are in the webinar 7. Tomorrow and on Wednesday, there are 2 practical training sessions on how to analyze the results of test performance studies, and you will have the occasion to go a bit more into details on really how to calculate all those performance characteristics that were mentioned in webinar 6 in the videos and in webinar 7. And after that, there will be one last webinar that will be kind of a summary on really how to organize a TPS and how to analyze the results. And during this webinar, the example of the TPS on TOB or FV will be used to really illustrate the whole process. So as I said, the link to the recording of this session will be available on our website. So do not hesitate to double check it if you need. Okay, so thank you very much to everybody, and see you then at the next webinar. Thank you. Bye-bye.
Bye.